All right, kiddos. Normally I have videos that cover the lessons completely. Unfortunately, I do not have a video for 7.4, so I just wanted to put something together really quickly so you guys could get the gist of the lesson, but I'm not going to be covering everything in great detail or doing every single one of the problems. What we are doing today is we're looking at similarity in right triangles. So the start thinking part says, how many triangles do you see in the following figure? So what we have here is we have a right triangle and we dropped down an altitude from that right angle and we're trying to figure out how many triangles we have. What you end up having is a small triangle, a medium triangle, and the whole entire thing, which is the big triangle. Okay? Now, the essential understanding, what we learned in class today, was that when you do this, not only do you end up with a small, medium, and big triangle, but when an altitude is created from the right angle of a right triangle, then three similar triangles are created. Now, down here is where we would actually put the proof, but I'm just going to explain to you how this works. So if you want to prove that this triangle, the medium one, is similar to the big one, we know we have SAS of similarity, SSS of similarity, or AA. So we want to use one of those methods, and we want to be as efficient as possible. Well, you know that both of them have right angles, so that would be one of your A's. And then in this case, angle B is shared, so that would be your other A, which means that the medium and the big triangle have to be similar by AA. When you look at this triangle right here, the small one and the big one, the small one and the big one are also going to be similar. You still have the reflexive property, and you also have the right angles that are in the small one and that are in the big one, so it would be AA again. So you now know you have a big triangle that's similar to the medium, and you have the big triangle that is similar to the small. And if the small is similar to the big and the big similar to the medium, then we have the transitive property that now says that the small must be similar to the medium triangle as well. Now, right here is wanting a similarity statement to talk about which triangles are similar. Now, one triangle here is like on one of its side and tall. This one is how you would normally, the medium is kind of how you would normally think of a right triangle, and then the big one is upside down. So what I like to do is I like to redraw them so that they're oriented the same. This is D. I'm going to look at the small one. That's D, C, and A. The medium is already how I wanted it to be. That's A, C, and B. And then you have the big one, which is A for the right angle. You have D right here, and you have B over here. And they already put it in the order of DAB, which is going in this direction. So I just list the other ones starting in the same place and going in the same direction. So the medium would be ACB, and the other one would be DCA. Okay, so that is what we're looking at. The majority of the lesson is all about the fact that if you have a right triangle, you drop down an altitude from the right angle, you end up with three similar triangles. And the proof that we talked about right here is that they can be proved by AA. Now, this can be a little bit confusing. Basically, what this is doing is it gives you part of a proportion and you need to figure out the rest of it. I would say this is the most confusing part of the whole entire lesson. So what we're going to do here is DA and DC are both either going to be the short sides, the medium sides, or the long sides. What do I mean by that? Well, if you look at the small triangle, there's a short side, a medium side, and a long side. When you look at the medium triangle, there's a short side, a medium, and a long side. And when you look at the big one, there's a short side, a medium side, and a long side. So when I look at DA and I compare that to DC, now this is the weird part. DA is not just short or medium or long. It can be multiple things. So if you are talking about the small triangle, that is the longest side. That is the longest side of the small triangle, but it is also going to be the shortest side of the big triangle. And now this over here, the bottom one, there is no two possible things it can be. It is only part of the small triangle and it's the shortest side. So what this means is that DA and DC, if they have to be the same thing, this one could be long or short and this has to be short, they must both be shorts. So what you do then is DA is coming from the big triangle it is going to be the shortest side of the big triangle, and DC is going to be the shortest side of the small triangle. And the reason I'm doing that is that's going to help me finish my my proportion over here. So AB on the big triangle, that's the medium side. So all we need to know is what is the medium side of the small triangle, and that is AC. I know that's kind of confusing. A lot of that comes down to the fact that, let me go ahead and erase some of this real quick. A lot of that comes down to the fact that certain sides, like this side right here, could be thought of as a short side or the medium side. It's the short side of the medium triangle, and it's the medium side of the small triangle. So that is why this lesson gets confusing, because a single side can actually mean multiple things for different triangles. So what I'm going to do is I'll do one more of these. AC and DC are either both going to be short, both going to be mediums, or both going to be longs. So let's figure out what they are and from which triangles. You have AC and you have DC. Well, this one could be the shortest side if you're talking about the medium triangle, or it could be the medium side of the small triangle. But this has no choice. This has to be, that has to be the shortest side. And since this could be short or medium and this is short, then they must both be shorts if they have to be the same. So AC is going to be the short of the medium triangle, and DC is going to be the short of the small triangle. And you need to know this information so that you can fill out the rest of it. Now we just say AB is part of what of the medium? AB, and this is where it kind of gets confusing as well, is that there is a medium-sized triangle and a medium-sized side. So this not only is from the medium triangle, but it is going to be, well, it's not going to be the medium side. It's going to be the longest side. So this one is the longest side of the medium triangle. So now I just need to know the longest side of the small triangle, and that is AD. Okay, and that's how you do these type of problems. Are they both shorts? Are they both mediums? Are they both shorts, mediums, or longs? And then which triangles? And once you know which triangles you're working with, then that will help you find out what's left over. Now the rest of the lesson comes down to problems like this. When you're looking at this and you're trying to solve for x, let's see, I think I might change this. No, let's leave it as is. So when we're, let's change it. I think this makes it easier for our first problem. Let's make that an x and this a 2. So when you are trying to solve for this, you need to remember the fact that there's 3 different triangles here and they're all similar. And you're going to be able to solve for this because technically you're going to have 2 triangles and you're going to have a missing side where you're able to set up a proportion. So you can go over and draw the small triangle, the medium triangle, and the big triangle and label what you have for each one of them and see which triangles you can work with. So the small one, that means that this is 2 and 8. I have gone over and tipped this on its side. So we had the triangle and it's standing up like this, and I tipped it on its side, 2 and 8. The medium side triangle, I have an X and a 10. And then the big triangle, the only side I have is the longest side, which is 12. If you're trying to set up a proportion and solve here, the triangle that does not have enough information is this one. So you are going to be able to set up a proportion with this. And you could set it up as 2 corresponds to X and 8 corresponds to 10. And that would give you your 8x equals 20. And then you would divide by 8 and divide by 8. And that would give you 10/4 or 5/2. So one way to do these type of problems is just draw the small one, draw the medium one, draw the big one, have them all oriented the same exact way, and then go ahead and figure out what triangle is not needed and solve for the side using the other ones. Let's go ahead and do that again, but let's change this to be X. So once again, I'm going to draw a small triangle, a medium triangle, and a big triangle. I'm going to label what I have for each one of them and figure out which ones have information that will help me set up a proportion. So this one is going to be 4 and that one's going to be X. This one only has a 10 and this one over here has an X, and then the longest side, which is across from the right angle, is going to be 14. So you figure out which triangle is not helpful. You can see this one does not have enough information, medium is not helpful, and you can now set up your proportion with the small and the large. 4 is to x, as x is to 14. Cross multiply. And for this problem, you would solve by square rooting. And for this one, I'm not going to simplify the radical. I'm just going to put it into a calculator, and that gives me 7.4. So that length is going to be 7.4. Okay, so one of the ways, and you could use this and ignore everything else from this lesson, but one of the ways to do this is just to go over and draw all 3 triangles, label them all, figure out which triangles are helpful. Now, us being mathematicians, we like to make things quick and easy so that the problem could just be set up for us, and we don't have to think and draw a bunch of triangles and stuff like that. So there are these shortcuts. I call them Hills and SAS. A certain triangle, when you look at it and has certain characteristics, you will be able to set up using something called Hills, and one of them you can set up using SAS. So Hills, the way you would know you are going to be using Hills is going to be, you will have the information for the hypotenuse. So it'll be like 2 and 10, and then you will also have the variable over here or a number over here, but basically you're not going to have the altitude as part of this problem. And rather than drawing this out and finding out you're going to work with the small triangle and with the big triangle, instead you can do the hypotenuse of the big one over the leg of the big one equals the leg of the big one over the side closest. So in this case, the setup would be the hypotenuse of the big is 12, the leg is x, and the side closest to it out of the 2 and the 10 is the 2. And that would do the same exact thing as drawing the triangles and figuring out which ones to work with. So it goes, this is to that is to the side closest to it. And if the x was over here, instead of putting it over 2, you would put it over 10 because 10 is closest. So that would be Hill's shortcut. Hypotenuse is to leg is to side. A SAS problem, the way you know that you have a SAS problem is you're going to have the altitude as part of the problem. Maybe you're going to have like an x here, a 2 there, and a 10 here. Look, there's the altitude as part of the problem, whereas this one, the altitude was not part of the problem. The way you do this is side is to altitude is to the other side. This is to 2 as 2 is to this one. So x is to 2 as 2 is to 10. And it sets up the problem rather than you having to look at the small triangle, the medium triangle, and the big triangle. If you're comfortable with this, then just do that and ignore this whole Hills and SAS stuff. Now, occasionally, you will have a problem like this one, where you have both Hills and SAS. And sometimes you can do SAS first and then Hills, and sometimes you have to do one before the other. This one, you could do Hills, 18 is to y is to 8, or you can do SAS, 8 is to x is to 10. You can do either one in whichever order you want. Now, if the x was right here, if you tried to, and this was the 8, and you tried to set this up as a Hills problem, you would have too many variables. You would have x plus 10 is to y, as y is to x, and you just have too many variables, and you would have to do the SAS part first. So I'm going to go ahead and do just a few problems to make sure you understand what I'm saying here. So this one right here, the altitude is not part of the problem, so it is not going to be SAS, it's going to be Hills. You just do the whole entire hypotenuse, which is 15, is to x, as x is to the side closest to it. If the x was over here, then you wouldn't have put it over 5 at the end, you'd put it over 10 at the end. So you end up with x squared equals 75, square root. And in this case, I'm just going to remind you how to simplify a radical. Remember, we talked about this at the beginning of the year. You divide by the prime numbers until you can't use that prime, then you move to the next one. So this one would be 3 times 25, 5 times 5, and 5 times 1. That brings a 5 outside of the radical, and a 3 stays inside. That would be the simplified radical version. Let's look at the next problem. So this one is both Hills and SAS. It's Hills because it has this over here, and it's SAS because you do have the altitude. In this case, if you try to do Hills first, then you are going to end up with too many variables, so I'm going to do SAS first. SAS is set up as x is to 5, as 5 is to 10. Or you could just draw a small triangle, a medium triangle, and a big one. but I'm going to solve it this way. You end up have 25 equals 10x, and when you divide, you have 2.5. So then you could go over, my voice is going out, sorry about that. You can change that to 2.5, and now just ignore this, and you could do Hills. Or you could have done the Pythagorean theorem here. Remember in math, a lot of times you could do things in multiple ways. If I wanted to do this as a Hills problem, it would be the whole hypotenuse, 12.5, over y equals y over the side closest to it, which is 2.5. And now you would get y squared equals, I think it's 31.25 if I'm remembering correctly, and you could square root. And since this is a decimal, you would not be doing this method. You would just pop it into a calculator, and I believe it gives you 5.5 or something like that. So to summarize what you missed, we talked about the fact that if you have a right triangle and you drop down in altitude, you end up with 3 triangles. That's cool. Well, they're also right triangles. That's cool. Oh, they're not only right triangles, they are similar triangles. And the fact that they're similar makes it so that you're able to look at certain sides, and certain sides are going to mean different things to different triangles, and you're able to set up these proportions. In addition, you can set up 3 triangles all oriented the same way, and when you are trying to solve for something, when you list out the sides that you know for each one of the triangles, you'll find 2 of the triangles that allow you to set up a proportion and solve for a side length. If you are a type like me that just likes a way after understanding how to do it, likes to have a streamlined way, we have Hills and SAS. Hills is used when you do not have the altitude as part of the problem. SAS is used when you do have the altitude as part of the problem. There you go. That's the lesson. Thanks for watching.